Given the rational function g of x equals x plus 1 divided by x squared minus x minus 2, sketch the graph. Determine whether the function is continuous. If there are any discontinuities, state what kind it is. Alright, so we got this rational function here. Okay, so we got the x on the numerator, x squared in the denominator. Right, first thing we should do is we should factor the denominator here, right? Hopefully, that'll give us the vertical asymptotes, and we'll see if anything else happens, right? So this we can factor into x minus 2, x plus 1. So actually, that turns out pretty good here, right? We end up with 1 over x minus 2. So now hopefully, right, the graph of 1 over x, right? The graph of 1 over x looks a little something like this. Get a vertical asymptote at 0, horizontal asymptote at 0. So what does this mean, right? Essentially, we're just going to shift this graph over 2 units to the left. 2 units to the right. Okay, so the vertical asymptote is going to be at positive 2 now. Okay. And then we should just be able to graph this as we normally would. Right, so we'll go down there at positive 2. Okay, and then we're going to go up this way. And the horizontal asymptote here is still at 0. So we do have a vertical asymptote. Okay, now, this one gets a little bit tricky, right? What is the domain of this function? What is the domain of this function? The domain is negative infinity to 2, union 2 to infinity. And we can see here, right, the 2's, they have parentheses around here, okay? And of course, 2 is not in the domain. Okay? So some people would say, yeah, it's discontinuous here at 2. Well, for rational functions though, right, remember the definition for rational functions, right, they are continuous along its domain. So actually, the function is going to be continuous here. There are no discontinuities. Okay, so it is continuous along its whole domain. You got to remember that for rational functions.